This week we're going to talk about motion and Newton's laws of motion. And there are several terms that I want to make sure you get straight in your head. These terms include vector versus scalar quantities, displacement as opposed to distance, velocity as opposed to speed, and acceleration. And we will go over each of these terms very carefully, and it's important that you keep these terms straight in your head. So, one of the people who spent a lot of time discussing motion was Galileo. And Galileo viewed the universe, the world, and all living things as special creations of God. Isaac Newton was responsible for the laws of motion that we will be discussing, and he was also responsible for something called the gravitational, the law of gravitation, and he was responsible for the mathematics of gravitation. Now, people understood gravitation, but he actually was able to figure out the math around gravitation and gravitational force. And then Albert Einstein basically launched an entire new generation of physics. Prior to that, everything was considered, quote, Newtonian, end quote. But then after that, everything was in an Einstein worldview. Now, quantities can be divided into two types, vector versus scalar. A scalar quantity is a measurement that has only a magnitude or a quantity. And an example of that is speed. A vector quantity, on the other hand, is a measurement that has both a magnitude and a direction. An example of that is velocity. One way to look at the difference between a vector and a scalar quantity is to look at the difference between distance and displacement. Distance is a scalar quantity and only represents the total length of the object's path. And it is path dependent. And the sort of purplish line represents the distance that an object travels. Displacement, on the other hand, is a vector quantity that represents the change in an object's position, both in terms of the length or quantity and the direction, and it is independent. And this is the important part, it is independent of the path. A straight line distance and direction from point 1 to point 2. So let's take a look at some problems that differentiate between distance and displacement. A cross-country runner leaves school for a 10-minute run, or 10-mile run. They end their run at Dairy Queen 1 mile from school. What is the total distance that they ran, and what is their displacement? So if we look at this, let's say this represents the school, this represents Dairy Queen. And these people ran a 10-mile path like that. But the straight line is 1 mile, and the actual run was 10 miles. So the distance they ran is 10 miles, and the displacement they had is 1 mile, because in the end they're as the crow flies 1 mile from school to Dairy Queen. Looking at the second problem, it's kind of interesting. A person skis according to this diagram. So at time 0 they start here. At 1 minute they're here. At 2 minutes they're here. And at 3 minutes they're over here. So what distance did they travel after 3 minutes, and what displacement what is their displacement after 3 minutes? Now the displacement is actually quite simple. They started here and they ended here, so it's going to be 60 plus 120 plus 60. So their displacement is going to be equal to 60 plus 120 plus 60, or 240 meters. Now their distance is quite different. They go from here to here first, so that's going to be 60 plus 120. So let me write distance down here. We've got 60 plus 120, and that's their first minute. And then they go from here to here, so that's in the second minute they go another 120. And then from here to here in the third minute, so that's going to be 60 plus 120 again. So this is 180 and 180. So they got 180 plus 120 is 300, so the distance is 480 meters. So both of these show you the difference between distance and displacement. Now let's look at a couple other problems. A car drives 215 kilometers west and then 85 kilometers south. What is the displacement of the car from the point of origin? Magnitude and direction. So the car starts right here, and first he drives 215 kilometers west. Then he turns due south and drives another, sorry about that. Then he goes due south and drives 85 miles or kilometers. His actual displacement is represented by this line right here. So basically what you have here is a right triangle, and you have the two arms of a right triangle. Well, the hypotenuse of a right triangle squared is equal to each side squared, right? And so the hypotenuse squared is going to equal 215 squared plus 85 squared. So the hypotenuse, this distance here, is going to equal the square root of these two sides squared. 215 squared plus 85 squared. And if you do the math here, you end up getting that the displacement here is 231.2 kilometers. And since displacement has a direction, it would be southwest. Now let's look at this second one, which is a little more interesting. A delivery truck goes 18 blocks north, then goes 10 blocks east, then goes 16 blocks south. What is the final displacement from the origin, which is going to be represented right here? So we've got 16, 10, and 18, and each block represents 528 feet. Well, if you complete this square, you see this is 2 and this is 10. And so this hypotenuse, c squared, is going to be equal to 2 squared plus 10 squared. So c is going to be equal to the square root of 100, which is 10 squared, plus 4, or 104. So the hypotenuse is going to be equal to 10.2 blocks. And we said a block was 528 feet, and so it's going to be approximately 538 feet. So the displacement is 538 feet northeast, if you were to give a direction to that. Now what we've been doing with this is something called vector addition. And vector addition is when you take the first displacement vector, which was the east or west. In the first example, it was the 215 kilometers west. That's the first vector. And we added the second vector, which was 85 kilometers south. And when you add those two vectors, you end up with a third vector that represents the sum, the quantity, and the direction in terms of the sum. And the way you can do that is you put the tail of one vector on the head of the second vector, and then whatever is left is the resultant vector. And so vector addition is when you combine two or more vectors. And whatever is left when you do vector addition, or the answer to vector addition, is called the resultant. In this case, the label is A plus B. Using vector addition, find the displacement of the following. So let's take a look at these. First one is 15 meters west and then 28 meters south. So 15 meters west, then 28 meters south. Again, that's not very good, 15. Again, you have if you want to write this as a vector, here's your first arrow, here's your second arrow, and here's your resultant arrow here. And so it's going to be, this is going to be the square root of 15 squared plus 28 squared. And if you do the math on that, you get 31.8 meters. And again, you're going to be going southwest. The second one is 35 miles east and 10 miles north. So here's your first vector, here's your second vector, here's the resultant vector right here. And this is going to be equal to the square root of 10 squared plus 35 squared, which is going to equal 36.4 miles. And the direction this time is going to be northeast. And the third one is 17 feet south. So there's your first vector. And then 21 feet west, your second vector. And then 7 feet north, your third vector. So your resultant is going to look like this. How do you do that? Well, one side is going to be 21 feet. And the other side is going to be 17 minus 7, or 10 feet. So it's going to be the square root of 21 squared plus 10 squared. 21 squared plus 10 squared, the square root of that is 23.3 feet. And it's going to be southwest. Now motion, up to this point we've been talking about displacement and distance, but now there's a scalar and a vector quantity that takes into account motion. Motion is when an object changes position from one point to another, and the study of motion and the forces that cause motion is called dynamics. Mechanics is the branch of physics that addresses the effects of forces on matter. So we will be talking about both a study of motion as well as the effects of forces on matter, because Newton's laws, which we will finish up the lecture on, we'll be talking about the effects of forces on motion.